This is a question from Puli. Actually, this question is from work, power, energy. If you are having the basic concept of work, power, and energy, you will understand this question. So, there is a lift. This is the lift cage carrying a mass M, and there is a counterweight of having mass M, and these two are connected with a chain. And chain is passing over a pulley, and this pulley is connected with a motor. And the question is, what must be the minimum capacity of the motor, that is minimum power of the motor, to bring this system to rest from a peak velocity of v in time t seconds. So basically it's a question from work, power, energy. So initially this mass system is having some kinetic energy. So both are having same mass, so the weight, both side weight, will nullify each other, so there is no effect of weight. So both the mass are having some kinetic energy due to this velocity v. So let me write down. So initial kinetic energy of the system is equal to half m v square plus half m v square. So you may get confusion at this point whether this will be plus or minus. See, easily we can avoid this confusion just by thinking in the realistic way. That means here we are going to calculate the power of the motor, that is the braking power is required to stop this system. So just think that there is a single mass, suppose this one is moving down and you have to stop this movement. So what you need to do, you need to apply the braking power required to stop this weight, that is half mv square only, if there is no mass on this side. But if both the masses are there and both are moving, so you have to stop this downward motion of this counterweight, as well as you have to stop the upward motion of this cage. So both sides you need to apply braking power. So you have to add both the braking powers required to stop both side masses. So it will be plus. So now the final kinetic energy of the system is 0, because we have to bring the system to rest. Rest means it will be v is equal to 0, so it will be 0. So change in kinetic energy is equal to mv square. So from the definition of power, what we know, power is nothing but the rate of doing work, right? If W is the work, then dW dt, that means the rate of doing work with respect to time. This is the definition of power. And again we know the work required to stop this system is equal to the change in kinetic energy, right? So Initially it is having this much of kinetic energy, and finally it is going to stop, going to rest. So the change in kinetic energy is mv square. So that means the work done required is equal to this change of kinetic energy, that is m v square. This is divided by t in t seconds. So m v square by t. So this is the power required to stop this system. Who will supply this power? The motor will supply this power. That means the motor must be capable of supplying minimum of this much of power. Then only the motor will be able to stop the system. So what are the options? Option A, half mv square. Option B, mv square by 2t. Option C, mv square by t. Option D, 2mv square by t. So easily we can see it's matching with C. So the answer is C, mv square by t.